Hello! Welcome to Teach Me Maths. My name is Jonathan Hicks. We're solving quadratic equations with the quadratic formula. Now, this can get pretty complicated, so hang in there. So far, we've only solved quadratic equations by factorising. With any quadratic equations, there's always two possibilities for how you solve it. And factorising is much easier than using the quadratic formula. So you always try factorising first. The problem, as I keep saying, is that most quadratic equations in real life won't factorise. So if you try factorising it and it doesn't work, then you have to use the quadratic formula. The advantage of the quadratic formula is it always works. So although it's a bit complicated, you're guaranteed to get the answer. So at least you know when you start with it, it's going to work. So in this video, I'm going to explain what the quadratic formula is and show you how to use it to solve quadratic equations. All right, let's have an example. I need to tell you what the formula is before we have the example. So in general, a quadratic equation looks like this. You've got some number, which we always call a, that multiplies the x squared term. Then you've got another number, which we call b, which multiplies the x term. And then possibly you've got some other number on the end, which we'll call c, and that equals 0. So that's what you call the general quadratic equation. ax squared plus bx plus c. A and b and c are just the numbers that go in front of the x squared, the x bit, and the number bit. So for example, if we had the equation x squared plus x minus 3 equals 0, then a here would just be 1. Yeah, we've got 1 lot of x squared. B is 1 as well, and c is minus 3. So you just have to match the numbers in front of the terms to the a, b, and c, and you figure out what a, b, and c are. So any quadratic equation can be written like this. The crucial thing to note though is you've got an equals 0 here. You must have everything on one side with an equals 0 on the other side. Very often when they give you quadratic equations to solve, they will be in this form anyway, so you won't need to mess around with it. But if they're not on one side, move it all over onto one side first. Now, I can tell you now that this won't factorise. If we try putting this into two brackets, x squared means it's going to be x and x. You need two numbers to multiply to give minus 3. So 1 times minus 3, minus 1 times 3 are options. And they need to add to give 1. Now 1 plus minus 3 is minus 2, that doesn't work. Minus 1 plus 3 is 2, that doesn't work. Nothing works. When you try factorising it, you don't get any options that actually work. So that means it doesn't factorise, and we're forced, as I say, to use the quadratic formula. Now, I'm going to put the quadratic formula up here in a minute, because we're going to keep referring back to it, and it's quite big and unwieldy. What I don't want to do in this video is explain where it comes from. It's quite hard to understand where it comes from. When we do some more advanced maths videos, I will explain where it comes from and how you get it. But for now, you just have to sort of take it on faith that some clever mathematician bloke came up with a way of solving quadratic equations that always works. So here's the quadratic formula. The quadratic formula. If you have a quadratic equation that looks like this, and remember you can make every quadratic equation look like that, then the solution is that x equals minus b, so that means minus whatever number you've got in front of the x, plus or minus, now you may not have seen this before, there are always two solutions when you solve a quadratic equation. Yeah, when we factorise, we'd have either one bracket is 0 or the other bracket is 0. The way the quadratic formula gives you your two solutions is it has this plus or minus. It's like a plus on top of a minus, and it means you have one solution when you use the plus, and you have another solution when you use the minus. So it could be plus or it could be minus, and both of them give you solutions. When I do the example, which we'll do with this one in a minute, you'll see how that works. You then have a big square root there, and inside the square root, it's b squared minus 4ac. Yeah, so you take the number next to the x and square it, and then take away 4 lots of the a number, the one in front of the x squared, times the c number, which is the one on the end. All of that has to be square rooted, and then everything there is on the top of a giant fraction. On the bottom of that fraction is 2a. So that's 2 times the number in front of the x squared term. That's the quadratic formula. It's very important, and I strongly recommend you learn this off by heart. Now, that might seem like a tall order at this stage, especially if you've never seen it before. It seems very complicated. I know this off by heart. The reason I know this off by heart is not particularly because I ever sat down and tried to learn it, but you find in real life you end up needing to use the quadratic formula a lot. Almost every quadratic equation you ever come across will require you to use this. So the reason I know it off by heart is because I've just used it so much. If you keep using something over and over and over again, eventually it just sticks in your head. But you'll find it a lot easier to deal with quadratics generally if you know this off by heart. So to save you time later, I recommend you just quickly try and learn it now, because then every time you use it, it'll be much quicker and you'll find it easier. All right, so how do we use it? Well, here's our quadratic equation. The first thing to notice is the values of a, b and c. So a here is 1, b is 1, c is -3. So we just write out all of that, replacing the a's and b's and c's by the numbers that you've got here. Okay, let's have a go. So x is going to be minus b. Now the number in front of the x, the b number is 1, so it's going to be -1. Plus or minus, we get our square root from here. Then it's b squared, well b is 1 again, so it's going to be 1 squared minus 4 times the a number times the c number. So often when you're first doing this, it's helpful to write it out. So it's -4 times the a number, which is 1, yep, a is 1, times the c number, which is -3. Let me just extend the square root, that needs to cover all those. That's on the top of our fraction. On the bottom of the fraction is 2 times a, yep, 2 times 1. So on the bottom of the fraction, it's just going to be 2. Work out what you've got. So x is going to be -1 plus or minus the square root of, well, 1 times 1, 1 squared is just 1. -4 times 1 is still -4. Times that by -3 though, you're going to get positive 12. Yep, the two minuses make a plus here. So it's 1 plus 12 inside the square root. We've still just got a 2 on the bottom. So 1 plus 12 gives you root 13. Now at this point, I usually like to split it up. So I'm going to divide the -1 by the 2, and I'm going to divide the square root by the 2 as well. So we're going to have two fractions, if you like, with a big plus or minus separating them. So it's -1 divided by 2, plus or minus, it could be either of those, and then it's the square root. 1 plus 12 is 13, divided by the 2. Those are my solutions. So the value of x that solves this equation, that makes it work, could be either -1/2 plus the square root of 13 divided by 2, or it could be -1/2 minus the square root of 13 divided by 2. Now that is quite complicated. I'm going to write out the two solutions separately though, and work them out just so you can see what it works out to be. In practice though, you would stop here. You don't need to do any more than that. You've simplified it as much as you can. Yep, you can't cancel the fractions down anymore, so you just leave it like that. There's no way of combining the square root with this bit over here. You need the two solutions for the plus and minus. You don't need to write them out separately. I'm going to do it in a minute, but you don't need to do that. You just leave your solutions like that. So that is how you use the quadratic formula. You just take the numbers, the a, b and c that go in front of the x squared, x and number bits, stick them in the quadratic formula, out pops the answer after a bit of simplifying. Right, let me just show you what these would work out to be. So we've got two solutions, one with a plus and one with a minus. So either x is -1/2 plus the square root of 13 over 2, or x is going to be -1/2 minus the square root of 13 over 2. Yeah, so these two have just come about from here. One of them using a plus, one of them's using the minus. Now, if you wanted to work out the kind of decimal number that you're going to get here, in maths generally we're not too bothered about that because decimals are not as accurate. This is the most accurate form of the answer. But sometimes you might want to know roughly how much is that. So you can shove it in a calculator if you want to work out how much it is. Let me just grab my calculator. So if we work out this, I usually do the square root bit first, I have to say. So I've got root 13 over 2, and then we need to take away 1/2 from that. So we get, this turns out to be 1.3 0.0277. I'm going to stop there. The decimal places here go on forever. This square root is an irrational number, which means the decimal places go on in a non-repeating pattern forever. So that's why we prefer this, because you can't write down the whole answer if you convert it into a decimal. You're going to have to round it, which means it's not as accurate. That's why we prefer this. But as a decimal, roughly it's about 1.3. This one, if we again shove that in the calculator, so we're going to have minus root 13 over 2 this time. Take away the half. We're going to get minus 2.3, give or take. And there were lots of decimal numbers on here again. So the answers are either 1.3 or minus 2.3. And if you shove those, as I say, back in the original equation, these are the values that will make it work. Now I should say, if you round this, if you take x to be 1.3 rather than the exact number, when you shove x equals 1.3 in here, you'll get something that's very close to 0 but not quite 0. And that's because you're rounding, you're losing some of the accuracy. You really need to put that into here, replacing x by it, and that will give you exactly 0. So as you can see, using the quadratic formula is quite complicated. You don't want to have to do this if you can avoid it. It's much better to factorise because it's just much easier to do. But as I say, a lot of the time in real life, quadratic equations won't factorise, so you have to use the quadratic formula. Alright, so let me just show you a couple more examples of how you use this. Once you've done it a few times, it's really not that bad. I know, as I say, it can seem quite overwhelming the first time you see it, but at the end of the day, you're just substituting numbers. That's all you're doing. The concept is pretty straightforward. It's just that involving the square root and the plus or minus and things, that's the bit that makes it a bit complicated. Alright, next one then, we'll have x squared minus 4x plus 2 equals 0. Alright, so a this time is still 1 again. B is minus 4, be very careful with your sign. C is positive 2. So, in theory we'd try factorising, but I've picked ones that won't factorise. So we use the quadratic formula. So x is going to be minus b. Now be careful. B is minus 4. So it's minus 4. And minus 4 is plus 4. Yeah, the two minuses make a plus. So it's going to be 4 plus or minus the square root of b squared. So that's minus 4 squared. Again, I'll write that out here. Minus 4ac, so it's minus 4 times 1 times 2. All of that is over 2a, 2 times 1, which just gives you 2 again. So if we work out the square root, plus or minus, minus 4 squared is positive 16. Minus 4 times 1 is minus 4, times that by 2 you get minus 8. All of that is divided by 2. So work out the square root here. 16 minus 8 gives you the square root of 8. All that's divided by 2. So our two solutions would be that x is 4 divided by 2, which is 2, plus or minus the square root of 8 divided by 2. Now, if you know what a surd is, and you've done cancelling surds, you should always cancel your surds. If you haven't got a clue what a surd is, then you don't listen to the next bit I say, okay, because it doesn't matter. If you just need to know how to use the quadratic formula, that's your solution, underline it, you're done. But if you're doing advanced maths, and you know how to cancel surds, you must always cancel them like you always have to cancel fractions. Root 8 is a surd, it will cancel, so you should cancel it. So I'm not going to go into the details of how you cancel the surds, but if you were to cancel the surd down here, you're going to get 2 plus or minus root 2. Okay, this will cancel down into root 2. So don't worry about that if you're not familiar with cancelling surds, but I just want to make the point that whenever you hit surds, you must always cancel them. Alright, so those would be your two solutions. It's either 2 plus this thing or 2 minus this thing. But that's how you use the quadratic formula to get your solutions. Right, next one. Okay, we're going to try a slightly harder one this time. So we're going to have a number in front of the x squared bit, which does make it slightly more difficult. But again, same idea. You would try factorising, you would discover after a while it doesn't factorise, and then you try the quadratic formula. So x equals minus b, so it's minus 2, plus or minus the square root of b squared, well 2 squared is 4, I'll shove that right in, minus 4 times 3 times minus 4. Be very careful with the signs here. All of that is over 2a, 2 times 3 is 6. So, got minus 2 plus or minus the square root of, well, 4 times 3 is 12, 4 times 12 is 48, and the signs, these two minuses will cancel into a plus, so overall it's going to be a positive. So you're going to get a positive 48 there, plus the 4 gives you a positive 52 altogether, and that's being divided by 6. So our final answer is going to be minus 2 over 6, which is minus a third, plus or minus the square root of 52 over 6. And again, if you're familiar with cancelling surds, you must cancel the surd here. It will cancel. You're going to get root 13 over 3. Okay? I'll do another video on cancelling surds when we get around to doing the advanced math stuff. But if you're not familiar with cancelling surds, that's as far as you want to go. That's your answer. Yeah, so you've got two solutions. It's minus a third plus the root 52 over 6, or it's minus a third minus root 52 over 6. Or obviously these if you're cancelling the surds. Okay, I'm going to do one more example before we finish of a rather special case, because there's something funny that can happen when you use the quadratic formula sometimes. And it's related to the square root. Okay, so we're going to have x squared minus 2x plus 2 equals 0. This looks like an easy enough one, doesn't it? You try factorising it and oh dear, it doesn't factorise. So we use the quadratic formula and you say x equals minus b, so it's minus 2. Again, be really careful here. The number in front of the x is minus 2. It's minus 2. Minus 2 is plus 2. So you need a positive 2 at the front there. Plus or minus b squared, or minus 2 squared is 4. Minus 4ac, so it's minus 4 times 1 times 2. That goes in the square root. And on the bottom it's 2a. The number in front of the x squared is 1. So it's 2 times 1, which is 2. So we're going to get 2 plus or minus. So 4 times 1 is 4. Times that by 2, you get 8. So it's 4 minus 8. 4 minus 8 is minus 4. And all that's divided by 2. And here we've got a little bit of a problem. What's the square root of minus 4? Now you do have to be careful here. The square root of 4 is obviously 2. Yeah, 2 squared gives you 4. But if you're trying to find the square root of minus 4, you're saying, what number do I square to get minus 4? And you don't have to think about it for too long before you realise there is no number that I can square to get minus 4. Because whatever the number is, the signs have got to be the same. Yeah? So if you do 2 squared, that's positive 2 times positive 2, that gives you positive 4. If you do minus 2 squared, that's going to be minus 2 times minus 2. Well, the signs are the same, they're both minus. Minus and minus makes a plus. So either way around, when you square something, it doesn't matter if it's positive or negative, the answer is always positive. So how can you get a negative inside a square root? Now, at this point it becomes rather esoteric. In advanced maths, it is possible to find the square root of a negative number. But at this level, we just kind of pretend that it doesn't exist. They have these things in maths at an advanced level called imaginary numbers, which are about as crazy as they sound, where the solution to this square root of minus 4 thing would be an imaginary number. It's not a real number, it's imaginary. And mathematicians mess around with these imaginary numbers, and sometimes they can actually be quite useful, surprisingly enough. The long and the short of it is, if you ever get to a point when using the quadratic formula where you have to square root a negative number, you stop and you just write down that there are no real solutions. And that's the answer. Now, you may have heard me mention in another video that for a quadratic equation there are always two solutions, and that is true. Even here there are two solutions. It's just that if you're having to square a negative number, the solutions are imaginary solutions. I know, it's madness, but we don't care at this level about imaginary solutions. We're only interested in real solutions. So if you ever have to square root a negative number, you just stop and you say no real solutions. There are two solutions, but they're not real numbers, so we don't really care about them. So that's the one exception you've really got to remember when using the quadratic formula. If you're square rooting a negative number, you just say no real solutions. All right, most of the time though, as I've shown with the other examples, you just plug all the numbers in, simplify it down, and out pops the answer at the end. My name is Jonathan Hicks and you're watching Teach Me Maths.